Rule 10. Statistics need a critical eye. From a workbook for arguments by Morrow and Weston. Some people see numbers, any numbers, in an argument and conclude from that fact alone that it must be a good argument. Statistics seem to have an aura of authority and definitiveness. And did you know that 88% of doctors agree? In fact, though, numbers take as much critical thinking as any other kind of evidence. So don't turn off your brain when you see statistics. Here's an example. After an era when some athletic powerhouse universities were accused of exploiting student athletes, leaving them to flunk out once their eligibility expired, college athletes are now graduating at higher rates. Many schools are now graduating more than 50% of their athletes. 50%. This seems pretty impressive. But this figure, that at first seems so persuasive, does not really do the job it claims to do. First, though, many schools graduate more than 50% of their athletes, it appears that some do not. So, this figure may very well exclude the most exploitive schools that really concern people in the first place. The argument does not offer graduation rates, but it would be useful to know how a more than 50% graduation rate compares with the graduation rate for all students at the same institutions. If it's significantly lower, athletes may still be getting exploited. Most importantly, this argument offers no reason to believe that college athletes' graduation rates are actually improving. This is because no comparison to any previous rate is offered. The conclusion claims that the graduation rate is now higher, but without knowing the previous rates, it's impossible to tell for sure. Numbers may offer incomplete evidence in other ways too. Rule 9, for example, tells us that knowing background rates may be crucial. Correspondingly, when an argument offers rates or percentages, the relevant background information usually must include the number of examples. Car thefts on campus may have doubled, but if this means that 2 cars were stolen rather than 1, there's probably not much to worry about. You also need to watch out for over-precision. This is another statistical pitfall. For example, every year, this campus wastes 412,067 paper cups and plastic cups. It's time to switch to reusable cups. Now look, there's no doubt the amount of campus waste is probably huge. But no one really knows the precise number of cups wasted each year, or at least allegedly. It's also extremely unlikely to be exactly the same amount of cups each year. Here, the appearance of exactness makes the evidence seem more authoritative than it really is. Be aware also of numbers that are easily manipulated. Pollsters know very well that how a question is asked can shape how it's answered. These days, we're even seeing polls that try to change people's minds about, say, a political candidate just by asking loaded questions. For example, if you were to discover that she's a liar and a cheat, how would that change your vote? In addition, many apparently hard statistics are actually based on guesswork or extrapolation, such as data about semi-legal or illegal activities. Since people have a major motive not to reveal or report things like drug use and under-the-counter transactions and the like, be aware of any confident generalization about how widespread they are. Keep in mind, using statistics in a generalization requires a critical eye.